Okay, so let's discuss a question from machine design. We have eccentric bolted joint where you have 5 bolts at a space of 100 mm and you have a load P applied, let's say at the right end, and the dimensions are given. And the diameter of each is 25, the bolt dia is 25. The total shear stress on the bolt C is given, and the total shear stress on the bolt B is asked. Okay, so that's interesting. What we will do is now, uh, just like any eccentric joint, we just find out the CG of these two. The CG of these two is obviously at the center of the bolt C. Okay, so this is the CG. And now at this CG, we try to resolve this load P. So this P is like this, as well as it produces a moment which is M is equal to PE. Okay, so we need to now get the stresses due to the load P as well as the stresses due to the shear stresses due to the moment M. So we call the shear stresses due to moment M as the secondary shear stress. So first let's get the primary stress. Okay, the primary stress on each of the bolt is basically load shared by all. So because 5 bolts, so on each of the bolt it's P by A into the area by the area of the bolt. So remember that the primary, this is the primary shear. So let me write down as a symbol of tau, because again sigma will mean whether it's at shear. Generally we use for tension or compression. So we use the shear stress, which is the symbol tau, P by 5a. This is the axial stress, this is the shear stress, sorry, and that is same on all the bolts. Now primary shear stress is same on all the bolts. Now bolt C, because it lies at the center, it lies at the CG, so it doesn't have, the bolt C will not feel, C will not have any, no secondary stresses because it's at the CG. So the total stress at the C is nothing but tau P only, and which is given as 4.1. So we can just use this formula. P is something which we don't know, we want to get that, into area. Area is pi by 4 d square, because 25 whole square is equal to 4.1 MPa. It's Newton per meter mm square, that is MPa. So that's what we have used, Newton, assuming that P is in newtons and the denominator is in mm square. So from this we get P as 10,106 29, okay, 2.9 actually. So basically 10062.9 newtons. Okay, 62.9 newtons is the force which we get. Now we need to calculate the secondary stresses. Okay, and because then only we can get the total shear stress on P. Now secondary stresses, we have a secondary shear stress constant called K, which is again divided by M into the summation of distances, yeah, sum of the squares of the distances from the CG. So the moment we know, so this is again, I mean, this is farther the bolt from the CG will have larger the force, secondary force, and then we can calculate this. So first we use this formula method to calculate this. This P into, the moment is P into eccentric, okay, and we get this shear stress force. So load is 10062.9, okay, and the distance of the CG from the load is P, which is nothing but, here is the CG, so 200 plus 800, it's 1000. So let's substitute everything in mm, and distances from the CG. Now distances from the CG is nothing but A is 200 square, B is 100 square, D is 100 square each. So basically 100 square plus 200 square plus 100 square plus 200 square. So this value, when I get, this is a secondary shear force constants, and this comes out to be 100.629 Newton per mm. Okay, so now let's say if I want to get the secondary load on bolt B, second shear load on bolt B, So that shear load on bolt B will be K into the distance of bolt B from the CG. Okay, so this is 100.629, okay, into 100, which is the distance. So this will be, we will be getting 100,629 Newton. Okay, now remember, now what is the direction? Now because of this moment, that the force that comes, this P will try to produce a force P like this, whereas the moment will try to oppose this force. So this is the primary load on B, and this is a secondary load on B, and both of them, if you are opposite in direction, if you look at the values are exactly same. The primary load is same on all the bolts, it's all downwards. The secondary bolt on B is upwards, it is like this. So B, if you look at it, because of the moment, B has a upward secondary force which is 100,629, because the moment is like this. So it produces on the left side bolts left of C, it produces a upward force. On the bolts D and D, it produces a downward force. The primary bolt load is same on all, it's all downward, 62.9. So the total load is primary plus secondary, and these cancel each other because this is primary. Looking at the figure, you can see this cancel each other. So the load, there is no effective load on the bolt, so the shear stress is also 0, because the shear stress is nothing but P total by area, and P total is 0, so shear stress on B is 0. So this is an interesting question. So the shear stress on B is 0. Thank you.